When we began making the Aquasorb in 2007, it gave food and pharmaceutical scientists a new way to look at moisture sorption through the dynamic dew point isotherm method, or DDI for short. Now we're launching a completely redesigned instrument called the Aqualab VSA, and it has a new set of capabilities. To explain the improvements that we've made to this instrument, we need a little bit more background on the two different ways that isotherms are measured. So the first way, which is the DDI method that I just mentioned, uses either totally wet or completely dry air. A small amount of that air is pumped into a sealed chamber that holds your sample. So for example, if it's wet air, the sample absorbs a little bit of water from the air, and then its weight and its water activity change. The weight change is tracked using a precision balance, while the water activity change is measured using our chilled mirror dew point sensor. Then the instrument repeats the cycle. Each time it does this, it obtains one more data point on your isotherm graph. So this method's strength really is its resolution. No other method can produce such a clear picture of the adsorption and desorption process in your product. It's also really fast. A complete adsorption and desorption cycle can be done in about 48 hours. The great thing about the Aqualab VSA is that it can now also run DVS, or dynamic vapor sorption isotherms. So the DVS method is one where the user actually controls the humidity level. So when in DVS mode, the Aqualab VSA pumps air at a specific user-selectable humidity through the sample chamber, which then monitors how the sample weight changes under these conditions. Each time the humidity is stepped up, the sample takes on more weight and then comes to equilibrium. This DVS capability is a big upgrade for users because it allows them to analyze the kinetics of reactions, or in other words, how long it takes something to happen. The ability to run both DVS and DDI isotherms might be the Aqualab VSA's most attractive benefit. Another improvement that we've made is on the Aqualab VSA's level of control. Users can program up to 20 stages into a single experiment. So a stage is just a set of conditions that a user wants to expose his or her sample to. For example, users select the method that they want to use, either DDI or DVS. They select the temperature, they select the beginning and ending humidity, and there are other parameters that they can change as well. So once a stage in an experiment has completed, the instrument automatically begins the next stage. This can be a little bit confusing, so let's look at how this works on a real sample of spray-dried milk powder. The Aqualab VSA comes with computer software, and we're going to use that software to set up the stages for this example. First, I tell the Aqualab VSA that I want to use the DDI method to adsorb moisture until it reaches a water activity of 0.6, and I leave the temperature setting at 25 degrees C. For the next step, I tell the instrument I want to use the DVS method to hold the humidity constant until weight stops changing, and then step the humidity up in increments of 10%. So we've already done this experiment, and this graph shows that data. As you can see, this product shows the advantages of using both methods together on one sample. If I had just used the DDI method, I wouldn't have seen the crystallization reaction that occurs at about 0.6 water activity units. But if I had just used the DVS method, I wouldn't have the resolution to see the glass transition that happens at 0.43 water activity units. We've made lots of other improvements to this instrument, but its combined DDI-DVS capability and its increased level of user control are the two biggest. The Aquasorb made isotherm science easy, accessible, and affordable. The Aqualab VSA builds on that history by adding new capabilities while also being the most affordable DVS-capable instrument on the market. For more information, please contact us or go to our website at www.aqualab.com.